Thank you so much for being here. My name is Ray. I'm a developer advocate for the Google Cloud Platform. And what that means is that I like to bring some of our technologies to developers all over the world, both on the Google Cloud Platform and also open source projects. And there are many open source projects that we have: Kubernetes, Istio, gRPC. And today I'm going to talk a little bit about Knative. And I also like to make some of our experiences better for Java developers. That's my focus as well. I've been a Java developer for many, many years now. And one of the projects I started with Google engineers is actually Spring Cloud GCP. So if you're using Spring Boot, if you want to try it on Google Cloud Platform, check out the project because it's got tons of useful starters and auto configurations for you. I'm also a contributor to JHipster that allows you to generate full stack applications. And I have my own project called JDefer. That's a promises framework that I started many, many years ago. Anyways, if you have any questions about this session, any feedback, please reach out to me on Twitter @Satanism. So first of all, show of hand, how many people here use Kubernetes already? Wow, just about everyone. OK, half of the room, more than half of the room. That's pretty awesome. I will go through something pretty basic and then something in depth about how Kubernetes works in order for us to understand a little bit about Knative and how do we configure it so that we can use it for our Java applications as well. Okay? So first of all, Kubernetes has changed everything about how we understand and do deployments and managing our applications across the landscape. Right? With Kubernetes, one of the core concepts here is that you are able to declare the desired state of your system, and behind the scenes, Kubernetes is able to reconcile and make sure that the desired state matches the reality, or vice versa. So if I want to deploy 2 instances of something, all I need to do is to use a well-defined API, well-defined nouns that Kubernetes allows me to define what that desired state is. In this case, I'm using the kind called deployment. And then I'm setting the replica number to 2. That means I want 2 instances. And then I can tell Kubernetes which container I want to run that will have 2 instances. Now, behind the scenes, of course, there's a little thing behind the scenes called the scheduler that's going to be running in what we call a Reconsolidation Loop. So what happened behind the scenes at high level looks like this. We'll push the desired state in a config file into Kubernetes master node that will be stored in a system in Kubernetes, like in a key value storage, or specifically maybe etcd. And then the scheduler is going to be running a loop that's going to check, oh, do I have a new configuration? Do I have a new desired state? If I do, what do I need to do to make that into reality? Right? So the scheduler is going to say, oh, I need to run 2 instances of Nginx or something like that. And it's going to see which of the nodes I can actually run this on in my cluster. And then we'll instruct the nodes in the cluster to actually start the instance, and only starting 2 of them because that's my desired state. So for example, if I want to do this fairly quickly, I can use the kubectl command line. I can say kubectl run something called Nginx. I can specify the image here. I'm going to use something from Docker Hub. And I'm going to say I want to have 2 instances, right? Oh, what happened? Let me see here. Delete deployment, Nginx. Maybe that's already there. And let me just make sure this is actually watching. And let me try this again. And there we go. I should have 2 instances of my Nginx. And then we can see at the bottom, I got 2 instances up and running. And because it is running in a reconciliation loop, what that means is that every time I change the reality, behind the scenes, Kubernetes will constantly try to make the reality into matching your desired state. If I'm changing the number of instances, or if I deleted one of these instances, now you have 1, and in the reconciliation loop, Kubernetes is going to realize that and say, oh, I need 1 more, and it's going to restart the instance for you. That is at high level on how Kubernetes operates. But I'm going to go into a little more depth on what happens exactly behind the scenes, because that's very important for us to understand. And once we understand how Kubernetes works, we will understand how everything else running on Kubernetes is going to work as well. So even though I have just created a new deployment, that specifies that I would need to run 2 instances of something, behind the scenes, it indirectly actually creates another resource, another document called the replica set. The replica set is actually the one that will guarantee or try to have at least 2 instances running. So a deployment object will indirectly create a replica set object, which we didn't really create ourselves, but it's actually there, right? And we'll get to how that got there in the first place. And then the replica set object is the one that's responsible to actually create the number of instances that I need, and these are called the pod, and that is what we're seeing here. Now we have 2 pods, right? So there's a layering here from a very high-level concept called the deployment that will generate a lower-level concept called the replica set, and then that will generate a lower-level concept called the pod. Now, behind the scenes, this is pretty much how this works. Now, the way I think about Kubernetes is that I don't know if anyone here uses an ERP system or work with an ERP system, the traditional IT system, right? The way that works is that you will put in an order through a UI. In this order, you might say, I need to have 2 widgets in my warehouse. And then behind the scenes, a physical person is there to say, oh, I need to order 2 widgets. So let me go ahead and figure out how to do that. And maybe I put in more orders with my suppliers. And then eventually, I get my order shipped. And I can then fulfill this order and put into the warehouse. But that is a manual process with a physical person behind the scenes. The way that Kubernetes works is by using programs or controllers behind the scenes to automate all of these processes. So in this case, I say I need to have 2 instances of something running. There will be a deployment controller that's running in a reconciliation loop to say, based on this document, what do I need to create to make this into reality? And behind the scenes, it will say, oh, I need to create a replica set. And then a replica set is created. And then there will be a controller behind the scenes that's also running a reconciliation loop and say, if there are new replica sets or if there's any changes to the replica set, I need to make that into reality. And then what happens then is that the replication controller will see a new replica set being created, and then indirectly it's going to create the pod documents and put that into Kubernetes. And at this very moment, these are just documents. These are just resources that's stored in the Kubernetes database somewhere. Nothing has run at this very moment. What happens then is that these documents would not know where to run the application. It does not know which node in the cluster this needs to run. And this is where the scheduler actually comes in. The scheduler will say, oh, I have these pod documents that has not been assigned to any node. The scheduler will then automatically determine which node, based on heuristic, which node these pods should be running on, and then write back to the document and say, the node name is blah. Right? So in this case, maybe node 1 and node 2 has been assigned to each of the pod. And at this very moment, still nothing is running on Kubernetes. We're just updating the document. And then the kubelet, the controller, will wake up in each individual node. So node 1 will have a kubelet, node 2 will have a kubelet. And node 1 will say, oh, let me watch for any of the pods that should be running on my node. And then I will make that into reality. So once the node name is assigned, the kubelet will receive it. And then it's going to actually start the container and then updating the status to the pod. And now you actually have a running system. That is pretty much how Kubernetes works behind the scenes. And this is very, very important to understand because this drives everything else, including Istio, including Knative, that is running on the Kubernetes system. Okay? So that is how deployment is controlling the replica set, which is controlling the pod behind the scenes. Okay? Now, the good news is sometimes maybe your workload may not fit this thing exactly. Maybe you have something very special. Or maybe you want to deploy a Kafka cluster. Maybe you want to deploy a Couchbase cluster of some sort. And maybe you don't want to use out-of-the-box constructs within Kubernetes. You can actually extend Kubernetes very, very easily by writing and creating your own resources. So in addition to deployment and stateful set and a few other things that Kubernetes give you, you can write your own resource. You can define what these resources are. And then you can hook into your own controllers to make things happen and making that into reality. So for example, one of the thing that my colleague wrote, Mark Mandel, is he works on this project called Agnes. Agnes is a project that helps you to run GAM-oriented workload on Kubernetes. Because GAM servers have very different characteristics than a regular stateless application. And so to manage the GAM servers, he actually introduced a new resource called the GAM server resource and a few other things that is defined and designed to specify what the GAM server looks like. And then behind the scenes, the controller will make that into reality, right? So the way that's done is by using a custom resource definition where you can specify and create your own resource. In this case, it created something called the GAM server kind. You can specify the plural names and the short names for it. And then also you can add validation rules to what data goes into this particular resource. And this is by using OpenAPI v3 schema. So you can specify every property and some basic validation rules there. And then you can then create the actual GAM server resource based on that schema. and then you can push this into Kubernetes, and Kubernetes will just simply store it. It wouldn't do anything with it, except that if you added your own controller, then the controller can be listening to the changes to these documents, specifically the game server document. And then the controller will then do what it needs to do to create the actual instances of the application and make them run. And so indirectly, the game server could say, oh, based on this definition, I need to go ahead and create a deployment document. And then the deployment document will create a replica set document, and so on and so forth. It's going to create a pod document. And then eventually, everything will be running on the machines. Okay? That is a gist of the basic, like, fundamental constructs that Kubernetes has, allows you to extend it. Now, about 3 years ago, I presented Kubernetes a few times, like around different conferences. And when I showed that how easy it was to deploy a container across an entire cluster of machines, and then killing one of the machines and everything got restarted, sometimes people would burst into tears, right? Like, it was the coolest thing that anybody have seen about 3 years ago. And I think we kind of normalized that, right? The fact that I'm showing this right now and people are like, oh, that's kind of normal, you know, kind of speak the word of it, right? It's pretty normal now. And however, now we are facing with other issues in terms of complexity. We got rid of a lot of complexity through Kubernetes, but we still have to do some work. So in order for me to deploy this thing properly, I have to write the code first, right? I got to write the code, and I need to build the Docker image, and then I need to write the Docker file. I got to do the Docker build, Docker push, and all that. And then I need to push it to the registry. And then I need to write my deployment, a YAML file to know how to deploy this. And then I need to figure out how to load balance it, or I need to write a service YAML file. I need to expose it on the internet. Maybe I write an ingress YAML file. And then I need to figure out how to do HTTPS and load balancing, and so on and so forth. There's still a lot of steps in between from getting from the code into serving on the Kubernetes cluster with the IP address. What it would be really nice is, of course, as a developer, I just want to write the code and deploy. And hopefully, there will be a higher level abstraction that can collapse all of these other things that I'm doing today manually and find a way to automate it. And that requires us to build these higher level abstractions, just like the similar way that the Agnes project is doing for the game server. This is where Knative comes in. Okay, so it's called Knative, so it's Knative. I know in the past people call it native, where the K is silent, or Knative, where K is kind of like a K. But it's called Knative. I think that's the official way to call it, right? So Knative offers you the building blocks, the higher level abstractions, through the Kubernetes native way, which is by using the custom resource definitions, to allow you to define and run serverless workload where you can hopefully get to the place where you can just write the code and deploy. And we will take care of all of these other things that you would do manually today, and we would automate it somehow, okay? That is at the gist of what Knative can do. So it's going to introduce some primitives to allow you to define your serverless workload. And when I say serverless workload, I really just mean workload that can be elastically scaled up to however many instances you need, and scale down to 0 when nobody's using it. Obviously, there are servers behind the scenes, right? So it's really a way to think about how do you account for running your services. It's basically starting on demand and scale down to 0 when you don't need to use it anymore, right? And it's an open source project that's being created by Google and a few other partners, where they contributed significantly into how this thing should work. You can definitely check out more on the GitHub page. But I'm gonna just show you the exact, some demos here. So fundamentally, Knative is built on top of the Kubernetes platform. So it can use anything that Kubernetes can use, including deployments, replica sets, and pod, right? All of these concepts are gonna be there. Now behind the scenes, it also installs and uses the Serverless Mesh by default, which is Istio. Right, so the Serverless Mesh allows you to take care of some of the distributed system cross-cutting concerns, like the retries, the load balancing, the circuit breaking, and a few other things, tracing and monitoring. Right, all of those things can be taken care of by the Serverless Mesh, so that when you deploy a function, when you deploy your application doesn't necessarily need to have to deal with these cross-cutting concerns, because that's all being taken care of by Istio in a way. And then Knative actually just introduces a couple of primitives, couple of custom resource definitions that allows you to deal with how do you deploy your application at the application level? How do you build it, right? If you want to have a simple CI/CD pipeline that knows how to turn source code into containers and run, we have a build definition that you can use. And then for some of the functional-oriented workload, function workload, then we have event-driven primitives as well. So you can define events, you can listen to events, and then we can propagate the events downstream to different functions as well. Okay, that is on the gist of what Knative can do. And the idea here is to make it as simple as possible for you to be able to run and operate your application without having to deal with a lot of these other things that we are doing manually, okay? And these are building blocks and for higher level abstractions that is to come. The way that you install Knative is pretty simple. If you have a Kubernetes cluster already, all you need to do is first install Istio, and then install Knative. These are just YAML files with a lot of CRD definitions and controllers behind the scenes, and it's going to bootstrap your environment for the Knative workload. Now, I have my environment already up and running, so let me just take a look at here. So my cluster here has the Knative pre-installed. Here we have the Istio system, where it actually has all the ingress and endpoints. So for example, if I get the SVC in my Istio system, what I'm going to see is the ingress or the IP address that allows me to access my cluster, and that's all predefined and pre-installed for me already. And then I have, of course, all of the Knative components. All of them are running in a different namespace. So the serving is here, the build is here, and eventing here. So let's take a look at what it would take to run something in Knative. I'm going to do it the basic way first, and then we're going to get into something more advanced and more automated as well. So let me get rid of my Nginx deployment. Nginx, I'm going to get rid of that. So yeah, go away. Yeah, there we go. And I am going to try something that I haven't been, I don't have a lot of confidence in. What I'm going to do is I'm going to create a new project here. I'm going to use Kotlin with Spring, of course, with start.spring.io. I'm going to create a new project here that's going to serve something on the website. I'm going to add GCP support so I can use some of the GCP APIs. I'm going to create something called cat-not-cat. Sorry, so I think there was a show where some startup created this thing called hot dog, not hot dog, right? So you can take a picture of the hot dog and tell you whether it's a hot dog or not. So I'm going to create something called cat-not-cat, because we all love cats. So it's going to use a machine learning API to kind of figure out whether the picture you upload is a cat or not. So I'm going to try to build this fairly quickly, and then I'm going to turn this into a container image, and I'm going to deploy into Knative as well. And then I'm going to check into GitHub, and we're going to see how we can turn this code from source to URL with just one file. And then we're going to see how we can do that, hopefully with just one command line as well. Okay? So let's see if we can make this work. I'm a little nervous. I guess you are too. So we will see. Now, the first thing I need to do is, of course, to add my dependency. So I will be using the Vision API here. Now, the reason why I'm doing this is because a couple months ago, I did a talk with Josh Long where we actually created something called, a lot of the times when you see serverless demos, they show you uppercasing, right? How do you uppercase a string? And we thought that was pretty boring. Like, why are we showing uppercase all the time? So I said, well, can we actually uppercase a cat? And in order to uppercase a cat, we have to determine whether the picture is a cat first, right? And that's why we ended up using for example, the Vision API here. Okay, so I'm gonna try to first of all use the Vision API to figure out whether something I'm going to create is a cat or not. So here we go. So here's my cat application. And in order to use the Vision API, for example, I'm going to do something pretty quick here. All I'm going to do is to, I think I have a shortcut here. I'm going to basically bootstrap my my annotated client. So this is the client library for the Vision API. Now, let me see if, why is the Bing not working? Oh, there we go. Yeah, hold on. Now, auto import. All right, done. So here we have the Bing. Basically, what this will do is to get the right credentials and create a Vision API client. And then I'm going to create a class called the cat-not-cat controller Okay, so all of these things are pretty straightforward. I'm going to import the request mapping. And I'm going to go ahead and, this is Kotlin, by the way, because it's nice and easy. I'm going to automatically inject the image annotator here with the client through the constructor. And then I have to get the image in. What I'm going to do is basically get it from a post mapping. I'm going to get it from a base64 encoded string. And it's going to be part of the request body. And then I think I should be able to do the annotate. There we go. So what happens here is to basically code the image annotator client. And then I'm going to make a new request. And it's going to send in the base64 decoded bytes of the image I'm going to upload. I'm going to do a feature extraction, right? And this is going to give me a response. And basically what I can do is to iterate through the response and see whether the API has determined whether this is a cat or not. All right. So the way I'm going to do that is I'm going to define whether this is a cat. I'm going to get the response. I'm going to use the first response because there's only one. And then there's a list of thing called the label annotations list. And then I'm going to say if any of the elements in this list, which is called the annotation, if any of the annotation have a description that is equal to a cat, and there's a confidence score that we can use. So annotation.score, there we go, is going to be greater than 90%. So I'm going to say 0.90. Yeah. So if any of those things, any of the elements is true that matches this predicate, then it is going to be a cat. And just to make sure, I'm going to also log the output of my responses in case I need to troubleshoot it somehow. So there we go, to string, is that right? Yeah, there we go. And then, based on this response, I'm going to say if cat, by the way, this is Kotlin, so they don't have the ternary operator, so I got to write the if statement as an expression. So if cat, then cat, else not cat, right? That's a pretty straightforward thing. And maybe to make this a little bit more interesting, what I'm going to do is to also inject a little variable I can configure. So I'm going to call this a prefix. It's going to be a string. And it's going to be called value. And, oh, sorry, let me make sure this is the right value. Value. That one I need. And I'm going to input this. And basically, I'm just going to say hello here, right? So I'm going to say hello cat, or if it's not a cat, I'm going to say not a cat. So there we go. That should do it. And I'm going to use the prefix here. So hello cat, or hello not cat, right? It's something that we can play around with the environmental variable. And that's it. How many people think this would just work? Nobody. Wow. Thanks. Yeah. I like the confidence here. Whew. That's a little scary. So I'm going to run this in IntelliJ. I'm going to test it first. And I'm going to build a container image. I'm going to show you how to do this, how to deploy this in Knative, and how that differs from deploying this in just a straight-up Kubernetes environment. Okay, so hopefully this is going to start the application. It started, so that's good. Basically, what I have is I have a couple of pictures I take that I posted on my Flickr, and one of them is the cat picture. I don't remember exactly where I took this picture from, but it's a reasonably cute cat. So I can work with that. And then I also have a dog picture because you always want to test it. Make sure that we're not cheating, right? I love this. This is my profile picture on Google+. But nobody uses that anymore. Anyways, so so I'm going to do a base64 encode, basically the cat picture here. I'm going to pipe it. I'm going to post it to port 8080. And then I'm going to make sure the data comes from the input string. And I'm going to set my content type is application text. And I'm going to make sure that we're doing a post like that. Post, spell. You can see I'm really, really nervous right now. So let's see if that works. I'm going to base64 it. Oh, yeah, OK. So let me do one more thing. Whew. There we go. Let me put a new line here. And hello, cat. It is, in fact, a cat. And just to show you that this is actually for reals, if I go back to here, we can actually see the output of the ML API. We can see for a fact that there's a cat in the description, and with almost 100% certainty that there was a cat. That's not too bad for a Vision API, right? So, and then we can do another test here. Let's just post a dog here, dog. And this should tell you, hello, not cat, right? Because it's a dog. And if we look into the responses here, there will be hi percentage of score here. Oh, it's a pug, actually, but also a dog, of course. A dog-like mammal, a dog breed. It's a mammal, and so on and so forth. Anyways, we get the idea, right? So this thing works. And now I need to convert this into a container image. With Knative, we want to make sure that there are ways for you to deploy applications either from the source code, or if you have an existing container, you can deploy from the container directly. So if you already have a container, you can just write a Knative definition to deploy the container, and it will take care of it for you. I'm going to turn this into a container myself, and the way I'm going to do that is by using something called Jib. This is an open source project from Google. It allows you to build Docker containers or just container images without using Docker. So this has no Docker daemon required. I can use Jib as a plugin for Gradle or Maven. I can then just specify the target image I want to push to. So I'm going to use GCRIO, Wise Coyote, 827, and I'm going to call it cat not cat as the image, right? What this will allow me to do is to hopefully, when this works, I'm going to go here, I'm going to do a compile, and then all I need to do is to call Jib build as the plugin, as the goal. And so it's going to do the compilation, and then it will automatically figure out from my my pom.xml to determine the jar structures that I'm going to build. And then it's going to layer everything for me appropriately based on the dependencies, the resource, and classes. Basically applies most of the best practices to build a container image, and then pushing it directly to the container registry, all done without having a Docker daemon, potentially, right? And that's already done. I have my application pushed to the registry just like that, okay? And then I can do something like this. I'm going to copy a little template from another directory here, project get nextio. I'm going to copy a little YAML file here called here we go, cat not cat, YAML, to here. Let me just open this up. So remember what we talked about with the higher level abstraction with the custom resource. In Knative, what it introduced, one of the things it introduced is a thing called service. This is actually a Knative service that is not a Kubernetes service. It's also not a Istio service. It's a Knative service. I don't know why they always pick the same names across all the stacks, but it is called a service, right? So what does that service do in Knative term? Well, it allows me to specify the configuration of my service. And configuration is really the combination of which container image I'm going to run, and also some configuration associated with this, right? So for example, I can change the prefix here, which is done through a environmental variable. I can say hello, or I had hello already. I'm going to say hi. And I can specify my readiness probe and all that. So this is very similar to what you get in Kubernetes deployment, except it's severely simplified. So you only focus on what container you want to run, basic probes, and also in vars, okay? And then here I can say run latest. What that means is that every time I modify my configuration, I also want to run the latest version of my configuration. And the way I'm going to apply it is, of course, this is a Kubernetes CRD. What that means is that I can just apply this into Kubernetes. And behind the scenes, the Knative controller will wake up. And then it's going to go ahead and figure out how to deploy this into my environment. And there it is. There's my cat not cat deployment that is downloading from my container image. And then it's waiting for the readiness probe to pass. And eventually, hopefully, this will be up and running. And there it is, up and running. However, the difference here is that I also created a number of things behind the scenes. It might look very simple, but this actually is serving on an endpoint. And the endpoint it's serving on is basically via that IP address I showed you earlier. So if I say kubectl get svc, right? And remember, we had a little IP address here. Where is it on the top? That one. So this is actually serving on this IP address. And this is done through a creation of a route in Knative. So a route in Knative is really just a way for you to specify what hostname you want to listen on and which revision of my application I want to route to. Okay. So if I open up this route, what we're going to see is something like this. This is also automatically created for me when I'm creating this serving or this service. Right, so here we can see clearly that we have, oh, sorry, let me just make sure this is cat not cat, cat not cat, there we go. Yeah, so here we have the configuration name, which is called cat not cat, which is going to take 100% of my request. And then this is the domain name that I configured with a custom domain name, basically using NIPIO. And if I actually post my picture to this endpoint, it will actually give me the response, right? And as you can see, I didn't have to create a service myself. I didn't have to create a load balancer myself. All of these things are just done automatically behind the scenes, which is quite amazing. So let me go ahead and try this. So here I had the curl, right? Oh, there we go. So I can do the base 64. I'm going to cat the cat into the curl stuff, right? And then I'm going to list, get it from std-in, do the application text, and then post it to the endpoint I just created. And oh, where is it? Oh, where am I? Oh, download cat. There we go. So let me try this again. Demo fails. So this is actually pushing it directly to the endpoint that I just created through the Knative serving or service definition. And you can also see that the environmental variable took place because remember that's how I configured it in my Spring application. So the invar code prefix actually took place, and now it's saying hi cat, right? So what happened actually behind the scenes? We created a higher level construct called a service, and it basically specifies what container you want to run and all the configuration associated with it. And that is stored in the configuration block. So the service contains the configuration. So when you create a service, behind the scenes, it also created an object for you called a configuration. And then based on that configuration, it took a snapshot of what that configuration is at that moment in time, and it creates what we call the revision behind the scenes. Okay? And every time you modify the configuration, it's going to create a new revision. So for example, right now, I have revision 00001. And if I change my YAML file here, and if I say not hi, how do you say that here? Do I say hello? Hello like that? No. Yeah? Yeah? Double O, like that, right? So I can do that. So I'm going to change my configuration. And then we're going to say cat apply the configuration or apply the service. Now check this out. What will happen behind the scenes is that a new configuration is being created and updated. And now we're creating another revision of our application with a new configuration. So for example, here I can see very clearly I have a Knative configuration that's just one. We updated it through service. And then this configuration actually have multiple revisions. Multiple revisions. Multiple revisions. Come on. What happened? What? Oh, did I? The revisions. Yeah, revision. I can't spell. There we go. So now you can see there are multiple revisions. Every one of these revisions, guess what? Creates a deployment behind the scenes. So every revision is tied to the deployment. This is how we control how many instances we are running. And every deployment creates a replica set. And then every replica set will create the number of pods that we need, right? And of course, behind the scenes, we'll also created the route. So from service, we have configuration. Every time you update the configuration, we have a new revision. And then we also created a route that allows me to route the traffic to a specific revision. Okay? So for example, right now, I'm routed to the latest version of the revision. So let me do this post again. Post cat. Am I in the wrong directory again? Yeah, I am. So let me try that. So I'm going to post this to the latest revision. And you can see that the new configuration just took place. It says hello now, right? Pretty cool. We can also ping this route to a specific revision as well. So for example, rather than using the run latest here, I can say pinged. And then ping to what? I can ping it to a revision name. I need to learn how to spell this, right? And I'm going to ping it to cat 00001. So I'm going to ping it to revision 001. Of course, I can apply this as well. And now my route will be updated so that all the subsequent requests will go to the revision 0001. And I can show you that as well if I show you the route for cat YAML. We can see now it's being configured 100%. That will go to revision 001. And then if I do this post again, of course, I should be able to see 001, which would say hi, I think, right? So this, hopefully, with the internet running, this would actually show up, right? So I'm just going to let it go. Oh, there we go. Hi, Nakia. Sorry. So it was saying hello because it was revision 2, and now it's saying hi because I'm updated the configuration here. Okay. Now there are of course ways for us to do this a little bit more fine-grained if you don't want Knative to do all of these things for you automatically. But just remember, from Knative service, we created configuration, configuration created the revision, and that inherently created the deployment, and deployment created a replica set, and the pod, and so on and so forth. And the route actually created a virtual service in Istio. So if you know Istio, virtual service is actually the thing that instructs and configures Istios on how to route the traffic. So for example, here, if I say kubectl get virtual service, code cat not cat, I believe. And if I do the OYAML, so basically from the route, it inherently configures the virtual service for me. And you can see the virtual service is actually a little bit more involved than just a route, because the higher level abstraction is creating these low level things for me. Okay. Now, of course, we can ping the route to a specific revision, and then what we can also do is to do, say, a canary release or a blue-green deployment, and so on and so forth. So if you have 2 revisions, we can configure a route to point to the different revisions very easily, and we can split the traffic between the 2. So for the example, then if I come here, I'm going to create a blue-green deployment example here. So the first thing that we're going to do is to create a new configuration. Now, you can create a configuration through a service, or you can create a configuration yourself. In this case, I'm going to create a new configuration myself, and that is going to be this other application called the route demo. And initially, the version 1 of this is going to be blue. And if I create the configuration myself, then the route will not be automatically created. And so I have to create a route myself in this case. Right? So if you use a service, we'll create everything for you. If you just create a configuration, you have to configure the route yourself. And at first, we're going to route everything to 001 100% of the time. So again, I'm just going to go ahead and apply this, 1.yaml, for blue and green deployments. And this will trigger the Knative controllers, will deploy the blue-green deployment right here. And then behind the scenes, we'll also create a route that is called the blue-green. And because I have this all configured to serve from a public endpoint, let me see, where did it go? Oh, there it is. Let me see if I can find blue-green. So I should be able to go to my blue-green route that is currently exposed on the public internet, and I can see very clearly this is going to blue. And that's the configuration I applied. Now, if I go back and go to the second stage here in a rollout where maybe I need to update my application, so I'm going to create a new configuration here. I'm going to update the existing configuration. I'm going to call it green, right? And so hopefully the background image is going to be green. By my route, I will have 2 potential targets to route to, but I'm still going to route only to the blue version for now, right? So let me apply this. So remember what happens behind the scenes with configuration. Update the configuration, a new revision is being created, and now I have a second revision that's automatically created. And the route is still configured to go to blue. And if I go back here to the refresh, I'm still going to blue. That's kind of expected. But then we can then configure the route for traffic splitting, right? So now I have 2 revisions, 00001 and 00002. I can split the traffic between them maybe by 50-50, right? So I can also apply this, stage 3 with the split route across 2 revisions. Remember what happens behind the scenes? We updated the route. It actually, at the basic level, fundamental level, it actually configured Istio with a virtual service to route it 50-50 to the backend. And if I do the refresh here, we should be able to see that every time I do a refresh, there should be a 50-50 chance to go to blue or green. Blue, blue, blue. Ah, there we go. There you go. And that works. Whew. So far, so good. So far, so good. It's all going as planned, all right? Of course, when you're done with your canaries and you spin out the traffic to the new versions, and now you're relatively happy with it, then you can shift the traffic 100% to the new version. And I can, of course, apply that as well. And this will, again, configure my load balancers and so on and so forth. By the way, this is all being load balanced at the HTTP level. So this is an L4 load balancer that's automatically provisioned and created for you, right? So you actually didn't really have to do some of these things yourself anymore. This is all provided through the Knative serving platform. Yeah. Now it's all green. Oh, good. Yeah. So now I'm on version 2, and now we're all going to green, right? Pretty cool so far. Now, one thing you might have noticed is that, wait a second, I thought I had 2 cat revisions. And one of them just went away. What happened? So what happened is that we haven't been routing traffic to cat revision 2. And that is because of the route that we created, right? So for example, here, if I say cat, I have pinged it to version 1. And now if I ping it to version 2, then we will be able to route traffic to it again. So let me just go ahead and apply it. But before I do, I want to show you something pretty cool. And you can just see that cat version 1 just disappeared as well. That is because Knative will automatically scale your workload for you. So you don't have to do this yourself. When nobody's using the app, then we'll, after a certain predetermined timeouts, we will scale this down. And now cat revision 1 is gone as well, right? However, upon the first trigger of this request, it will actually automatically spin up the pod for you. So now you can actually serve traffic. The way that this is done is by actually configure behind the scenes the Istio virtual service. Let me show you what that looks like. Virtual service for cat OYAML. When we spin down the application to 0, we actually update the virtual service so that when I'm trying to hit cat endpoint, it will route my traffic to this very special thing called the activator service. What the activator service will do is to receive this request, know where this request should be going to. It will queue the request up. It will tell Kubernetes to spin up a new instance of my application. And then once the application is ready to serve, the activator will then forward the request to the target environment, okay? So right now I have nothing running. And if I make another request for the very first time, it will go to the activator, right? It will spin up my new pod. And it's going to wait. It will hold down to the request until the new instance is up and running. And then eventually, once this is ready, it will forward the request to this particular instance. Now, if we actually watch for the virtual service configuration here, we can see now it's also being reconfigured so that rather than going to the activator, now all of the subsequent requests will go directly to cat, okay? And there it is. So basically, I had nothing running. It was scaled down to 0. And based on this first request that came in, went to the activator, we spun up a new pod, and then once the pod is able to respond to the request, we forward the request to it, and that is how you actually see the response coming back. If nobody is using this app for the next 7 minutes or so, this pod will again terminate. We'll also automatically scale this out for you based on the request per second configurations or whatever. So if you have more requests being queued up, we will spin up more and more instances for you automatically, okay? And that is what defines Knative more or less as a serverless platform for you to run your applications. Or at the same time, it can still interop with everything else that's running in Kubernetes, all right? Now, the other thing that is pretty cool, and this is the one thing that I really, really want to show, is that so far what I've done is I created the app, I containerized it myself, right? And then I instructed Knative to deploy my container. And behind the scenes, we deployed everything else for you. In Knative, there's a concept called the build. A build is basically saying, where is the source code? And what is the target name of the container you wanted to build to? And then in between, there will be steps, a series of steps that would compile the source code and build the container image and so on and so forth. And then after the build is done, we will actually do the actual service deployment for you. So this is really a very simple CI/CD pipeline that you can eventually create out of the box in Knative. The way that you create this is by potentially, well, first of all, we need the source code somewhere. So this is what I'm going to do. Why don't I just go to GitHub, and I'm going to check in this code. If I can still remember how that works. So I may need some help here. So I'm going to just create a new repository here. Let me see here. Yeah, new repository. I got many here. And I'm going to code this cat for GFL, new repository. So I'm going to create this repository. And then here I'm going to do a git init. Yeah, very good. And then I'm going to use the SSH endpoint here. So I'm going to commit, first commit. Can I do that? No, git add. And then git commit. All right, very good. And I'm going to add my origin. Oh, there we go. Add my origin. And I'm going to push it to my repository. Hopefully that still works. Yeah, very cool. So I'm just pushing something to my GitHub right now. Okay, and if refresh, I got my code, which I just created just now. All right, whew, scary stuff. And then what I can do is to define how this thing can be built. So I'm gonna go into my Kubernetes directory. I'm going to copy another file out here because it takes some time to write this file. So I got something queued up. I'm gonna say project git is in here, and then seeing I'm gonna do git build. All right, and there's the app.yaml to here. All right. So what we're going to do is to define the service again. And I'm going to code this cat from source, okay? Just so I can differentiate from the one I just created. And here in the configuration, rather than deploying a container that I've already created, what I'm going to do is to deploy directly from the Git URL. This is pretty cool. So rather than using whatever I just had, I can go ahead and use my URL here. So let me see, how do I do that? Use HTTPS. So I'm going to copy and paste this URL here. And then, of course, from the Git, we can specify what revision we want to build from. So this could be a tag, this can be a branch, and this can also be master. Okay. Now, how do I actually know how to compile this app? Every app is different. And the way that we're going to be doing this is by using the build template. And this is probably one of the coolest part of this whole thing, which is, where's my browser? There we go. So there are plenty of different build templates we can use. Some of them will take a Docker file. So like Knative, this will take a Docker file directly. What I'm going to use is called jib, okay? So there's a build template called jib. I have this pre-installed. And there's one that's specific to Maven. What this is really is you can define how you want to build your application through a series of parameters, but also a series of steps. So here are the steps. So the default step is to check out the source code. And then it's going to do a build here by running Maven. And it's going to use the jib plugin to build a container for me based on the image that I specified. This is really cool because it also works on any Java application that doesn't actually have jib defined in the pom.xml. If you don't have jib defined in your pom.xml, this will still work, which is really cool. And so here I can specify the different images, the image name. So, so this I'm going to call it cat. And I can also specify the cache so that this will be utilizing the Maven cache. So if I have this pre-built already, this will utilize the cache. Now check this out. For the image, I'm also storing the name of the image in a little variable. And I can reference the name of the image here, so I don't have to retype the image name twice. Okay? And then hopefully this will just work. Now I think I only have 2 minutes left, or 5, or whatever. Yeah, about. And let's see if this works. Woo! It's a little bit scary. And or actually, I can deploy whatever I want off of this, right? So for example, let me go back to this environment. Let me just do something else here because of the time. I'm going to go ahead and deploy this one instead, app.yaml. And see if that would be a little bit different. So I just created another one just because of the time. But you can see the first thing that it does is to kick off a build. This pod, this thing right now is actually performing the build. And I can see what's happening inside by looking into vision-00001. This is building from one of the GitHub samples that we have that runs the Vision API. And you can see that it actually checked out the code. It went through and run Maven. It's downloading some of the dependencies. And then using jib, it actually is pushing to the repository, right? It's doing all of these things. So it's doing the compile, jib Maven, and here's the containerization step. Okay. And this is the part where we can actually deploy Java applications really, really easily. You can, of course, write your own build templates with your own steps on how you want this to be done, right? But out of the box, we have jib templates that you can use. So given any source URL, I do mean just about anything that runs on Maven, we can turn that into a container image, and there's the application up and running. That will be scaled down to 0 when nobody's using it, and scale up when a lot of people are using it. And this will then, of course, create a route. And here's the vision route right here. So I can see what this route is, get route. Let me zoom in a little bit. Oh, vision, zoom in. There we go. So here's the route. And you can also go here if you want, if you can remember this long string. But I'm going to go there right now. And remember, I just created this from the source, deployed it through Knative serving, defined the source URL, define which template I want to use, which is the gib build template. And it builds the application for me, builds the container for me, created the load balancer, routing it through Istio, automatically scaling it, and here's my application. And here I can actually give it a little picture if I want to. And let me see what this sample is. Oh, that's pretty good. This is a picture of, I have no idea. All right. So let's see what, oh, this is Linden. Yeah, there we go. So let me run this through, right? This again serving through Knative, and we can see that this is a metropolitan area, it's a city, and so on and so forth, and that is my application. And that is how you can actually configure your Knative cluster to be able to build your Java applications behind the scenes. Now, because of the time, there's much, much more. One last thing I just want to say is, in addition to just serving via HTTP, we also support event-driven applications. So we can define your events with the source, the types, and actions. You can define channels and subscriptions, and we will interact behind the scenes with PubSub or Kafka or other type of queue systems, and we can actually allow you to trigger functions seamlessly, no matter what type of backend messaging system you are using. Okay, so with all that being said, right, Knative is just a really nice way for you to get rid of some of the toils. Then you can just write code and deploy. And I'm gonna scroll down here very quickly. So if you want to give it a try, you can check out a really nice tutorial that I put together with a workshop tutorial. So you can try Spring with Riff and Knative. And then you can find the installation documents here as well. And it is an open source project. If you have any questions, join the Slack, join the community. And thank you very much for your time. I really appreciate it.